Welcome to a new test and teardown video. This time it's a Grundig and also H&B, also very famous in Germany. Of course, this one is a German DC power supply. It's of course a regulated power supply. The cool thing about this one is all those outputs. I mean, look at that. It's really 6 individually regulated voltages, but they are in 2 and 2 connected together, so they share the same ground. So let's look at the first one here. This one is the main output 1. It's a positive from 80 volts to 350 volts variable, right? 100 milliamps. And it's of course these two. So the ground here is shared with a variable negative supply. And this is of course like an individual isolated supply. And then we go to the next one. So this is number 2. Again with the same specifications. So we've got 2 high power supplies, but now the negative is a little bit different. This one can give minus 50. So I don't understand exactly why they made this one different, more negative. But okay, if you want more, then yeah, I don't know. Well, and then number 3 is 50 volts to 250 and then half the current. And then again, there is a negative variable supply that shares the same common here. All right, and the meter, this is a funny thing. So this meter here is called number 4. So number 4 meter, you can switch between the 4, 4, and 4. And then you can see this one is the minus 10, minus 50, and minus 100. And that will be the 4 different ones. Clickety click, and then we can see. Oh, so that is the negative supply here, and we can read the voltage on that meter. So far, so good, right? So what about that one? So this is number 3, and I bet this is the number 3 voltage output. And here's the funny thing: the J, you push and hold this, and now you can read the milliamps. So that is how it is. You can't. Why isn't this a flip up down something with hold? Why would you do this? Maybe voltage is much more important. This is something I do not understand exactly why it's made like that. We also got output. So this switch is, as far as I can see, the output on off of this output here. But we still have filament and we still have high voltage behind this on everything else. But it's only the output here we disconnect. But the fuse is way deeper in the circuit. And yeah, what else can I say? We got also quite a lot of filament outputs here. And again, this system down here, we have a 0 here, and then all the positive, it's not positive, but all those, they are kind of connected together. So this is one output system, and then there's another isolated system right here, and again with more or less the same voltages, but of course again some special voltages. So yeah, that's how it is. You can put these in series and all those kind of things if you want to. And yeah, I just totally love this. It should be from about 1955 to 1960. And this thing is 25.1 kilos. So this is the back of the unit. As far as I can see, we got 2 mains fuses. And that should be the voltage selector. As far as I can see, I haven't yet figured out how you dial this. It seems not to be responding to anything. So I'll try not to mess this up, because Hopefully it's gonna work. And that is our fantastic label here. It says it's type number 6007 and the serial number. And I don't know exactly what that is, 110 and then 220. So that's probably the two different voltages you can adjust this for. And we don't know how many watts. I hope this one is connected for 220 because as far as I heard, this one should work. But none of these potentiometers move. Oh, there's one that moves. A little bit stuck, but yeah. Oh, okay. I could probably move it if I really wanted to. So this is something I need to fix. And luckily I know the cure for that problem. So I will show you my secret recipe and we'll fix that. I see a little nasty thing here. Somebody put a label on the front. That is something you should tell everybody not to do. I promised I was going to show you how to fix the potentiometers. So remember, I tried to turn a few of these and all of them, they were like super duper stuck, except this one. No, it was this one. It was number 2. It was really nice and loose and perfectly fine. And all the others, I couldn't really move them with my hands. So here's the trick. I removed all the knobs. And first, I'll take one of these. Whoopsie doopsie. This is alcohol, pure alcohol, as high proof as possible. I just use, something like this. Super duper high proof. And then I just put it here on the shaft. So there's so you can see it all the way around. You have a lot of alcohol right there. And then I take another knob and I screw it as high up as possible, like this, right? So that there's plenty of room for the alcohol to still be on the shaft, obviously, right? This one is the one using a normal screwdriver like this. So it will stay in here. And then I can just take, let me show you this here with both of my hands like this. And then I just do like this. Dip, 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 dip. First, of course, I have to loosen it, here by taking here and do it really, really hard and all that. And then it gets softer and softer and softer. And then eventually I can do this or massage it a lot so it gets all the way in. But the problem is alcohol evaporates and it ends up being really bad if you don't add contact 61. This one is not as thin as alcohol, so you can't really start with this. That is the problem. So this is a 2 solution. So you do the alcohol, and then when you can move them, then you start to add contact 61 like this and let it soak in a little bit. And while it is still wet like this, I just go here now and then, move the knob to the next one, and then move it around, use my fingers. Okay, fantastic. Next one. See? It's not a real big thing, but now all of them moves really, really nice and fantastic, just like new. And now it's going to stay like this for a long, long time. And now I can put on the original knobs. But before I do that, I clean, of course, the entire surface here so it's nice and shiny and fantastic. I love it to be really nice and clean. And then we can play with the instrument. So by the way, when we put on the knobs, here's another classic problem. I see this done wrong all the time. People just put them on and then they screw. What happens with this system is it actually pulls a little bit down like that. So it pulls the shaft out and it pushes this part of the knob all the way down into the potentiometer, and this creates all sorts of problems. So what I do is I just put it like this, and then I lift it just a half a millimeter, just a tiny little bit, so you can just feel it with your 2 fingers like that. Tiny little bit of lift, right? So now it's lifted a little bit, and I didn't tighten it. I just have it really, really loose. And then I move it. See, now I felt the stop, but it's so super loose. I can then adjust it for the right scale, and then I should be able to tighten it real good and double check both ends of the scale is correct and all is nice and fine. Haha, they're all so nice. Oh, funny sound in this one. So that's the little trickety trick here. This is just a wonderful, wonderful, beautiful unit. I totally love it. And there's just so much nice, and the whole way that everything is aligned with the 4 transformers. Of course, you want all the steel to be as low as possible. You want all the tubes to be as high as possible. And look how they are mounted in a zigzag like this. And this is, of course, to help the tubes to cool as much as possible. Everything is just fantastically smart. And yeah, I took out one of the EL156 just to show you. This is a beautiful, beautiful tube. I cleaned it so it's nice and shiny. And of course, I don't know if you can see this, but never ever clean this area with the label on your tubes. You don't even touch it with your fingers, because some of them, it will go away if you just touch it, and you never know. So that is why I don't even touch this area of this tube, because it is a unique, beautiful tube. Damn, it's big. This one has a broken tip, or this bottom part here. This is also used for alignment and centering and all that kind of stuff. And this, because this is broken, it is possible to put in the tube wrong into the socket, because if you look here at the socket, we have this center steering system here that handles the tube direction, right? So this you really, really need to be careful about. And also, because this is broken, you can see this little glass thing that sticks out there. Now it's super fragile. And yeah, I have to be careful when I put it in again. So I'll just leave it here for now. And yeah, I think I should show you. Yeah, I will show, of course, schematics and all that kind of stuff. But first, I just want you to have a little fast preview around here in the real world, and then I will show you the schematic. Then it's easier to understand where we are, right? So you see the 4 transformers. 2 of them, they are exactly the same. And remember, when we went through the front plate, we saw that we have the 2 high power, the highest voltage and the highest current variable power supplies. They, of course, use the 2 EL156 tubes. So that transformer goes to that tube, and that transformer goes to that tube, all right? Then we have transformer 3 that goes to the next variable power supply. And since this one is not so powerful, they also have space in this transformer for the filaments to the other 2 outputs. So those are driven by this transformer. And then the last transformer, that's all the filament outputs. And this is easy to see because of all those thick wires. They go, of course, to all the filaments. So that is super nice. Also, the way that they have numbered all the tubes. See, number 1, 2, 3, 4, 5. And they count them like this because all those tubes, that's the first power supply. Okay, then we go to the next power supply over here. 6, 7, 8. And where is number 9? Is down here. 9, 10. Right? So those tubes here, that's the second power supply. It's so nice and easy to figure out where are we. Let me show you a schematic. First I will show you a schematic with all the transformers numbered and all the tubes, locations and all their numbers and all that. So it's super easy for you to figure out where are we and all that kind of stuff. And then I will of course show you a nice schematic without all those numbers. And then we can dig in a little bit deeper. So this is how it looks after my little cleanup. Why do I want to clean up all those tubes? It's because they were covered with quite a thick layer of old dust. And as you can imagine, they run really warm. And warm dust smells really bad. And it's not funny to use a really nice old instrument like this and have a very bad nasty smell. So that is why I want to clean them, because clean glass doesn't smell. And then you can have a lot of fun playing with this instrument, and then it's nice and fantastic. Here is the schematic of this power supply, and I want you to note here on the full schematic, we got 3 individual schematics, and they are very much the same. The 2 top ones, they are exactly the same. That's the 2 high power outputs using the 2 beautiful EL156 tubes. And then the bottom one is using a much smaller EL84 tube, but other than that, it's exactly the same circuit. To the left, you see the 4 transformers, and again, you'll notice that transformer 1 and transformer 2, they're exactly the same. They drive only the 2 top main power supplies, and then the 2 transformer 3 and 4, they are not the same. So transformer 3 drives the last of the power supplies, and since that power supply is much less output power, half of the power, that means there is a lot of space on the transformer core to fit all the filaments. So this is where all the filaments for the different power supplies they are located. And then last you have the last transformer 4. That is the one that is doing all the filaments for the external systems. And again, this is of course individually fused. So in case you short circuit or overload your filament stuff, you will have individual fuses for that transformer. So that's quite nice. So since all the power supplies are identical, I can just zoom in here on the first one and then briefly explain the schematic. First, I want you to note that the bottom power supply, the negative 0 to 10 volts, that is simply a potentiometer from a high voltage regulated negative supply, and that negative supply is just there to make the top power supply work. All right, so those negative, I think it's about 200 volts negative, that is simply voltage divided down to a 0 to 10 volt output with a very high output impedance. The idea is this very weak output is only a supply that is used for grids, for tube grids that means close to zero current. So that is all you use these for. And then the top one, at the very top center, you have tube number 1. That is our EL156, the primary pentode. So this one is just like a cathode follower, and they use the EF804 here as a pentode. They compare two different voltages and then control the output power pentode with a feedback system. And the output voltage potentiometer is connected to the output to the left of switch 4. And this is your output enable sort of switch. So that means this power supply is always on, always regulated, always ready to rock and roll. And then you just switch the output on and off. Also, I want to show a little standard trick. If you look to the left, you see the capacitors, the high voltage capacitors. It's actually 4 capacitors, 2 and 2 in series. So we have quite a lot of voltage here in this place. Also note, we only have 1 inductor. This is the filter inductor between the 2 capacitors. If you're going to build a tube power supply one day, or any other power supply for that matter, where you want to have a good isolation, a noise isolation, ripple isolation away from your rectifier bridges, away from your transformers and all that kind of stuff, I really want you to consider to do it a little bit different from what they have done here. Because if you split that inductor into 2 halves, so you have 1 at the top and 1 at the bottom, of course half the value you need, you'll see now that you have isolated the entire left of those inductors away from your nice quiet circuit. And that means rectifier bridges and transformers and mains, whatever comes from mains, whatever is transferred via the capacitance in your transformer and all that kind of stuff, is now completely isolated away. So that is what I recommend you do. Here we zoom in on switch 3, and that will be the switches on the front panel called J. So that's a little bit funny. They don't explain exactly what they're doing. But the idea with that switch is, if you don't push it, you are now reading the voltage. So there's a resistor called R32. That is where the voltage measurement goes through switch 3 into the voltmeter. And you see the top part of switch 3. It's actually short-circuiting R31, the resistor we're using to measure the current. So that is a little bit odd. Why are you short-circuiting the sense resistor, and then when you push the switch, then you add a lot of series resistance to your load? Now your output voltage will drop, and now you are not measuring what the voltage is on your output. I mean, I would definitely recommend modifying this circuit so the sense resistor is always there, and then you can measure the output voltage to the right of the resistor, and then you can measure, of course, the voltage drop over that resistor, and this will tell you the output current. I mean, that is a little dummy made. I really try hard here to get everything into the picture, because this is going to be my first power on. I think the switches here, there's a color mark inside a round circle, and here is a round circle without anything in it. So I kind of just think that with stuff inside the circle, this gotta be on. And it's the same down here. They're just black inside a circle and then an open circle. I don't know. This is just, if I'm wrong, then I don't know what. I crank down all the outputs, voltmeters, and my load here is also serving as a nice voltmeter. So we should be able to see output is off and no load on that one. And then I just turn on my mains and then carefully crank it up. Yes, it was on. And I already get voltage output. And we're using 60 volts, 16 watts. And it's going down. So I just wanted to see that we get some heat up. Output voltage is definitely getting up. And why is it negative? It's because we probably got some resistors to a negative supply, right? Okay, I'll just crank it all the way up. Yes, we get some light. That is 140 volts. It's using 60 watts, so this is perfectly fine. I am now at almost 200. And I just continue. 190. I want to stop at 220. Like that. Here we go. 220. I better write this down so we can remember what's going on here. Because at 220, we got 120. It's dropping a little bit. 120 watts at 223 volts. Okay, fantastic. So what's going on here? This output here is the one that should be, let's zoom in a little bit here. It should be from 80 volts to 350 volts, and we got 64, right? So what if I move this one? Yes. And voltmeter up here is also moving. All the way up, and we got 324. It should go, the official should be 350. Okay, let's take that one down again. Wow, so this is one of the EL156, so that is good. And that one over here, where is that going? This one is going to my load. It is that one. So that was 100, 200. Oh, oi, 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 oi. So this one goes a lot higher. See, that is interesting. And it was supposed to go only 300 and... Okay, here we go. So that was probably just some regulation stuff. So this is 334, as you can see. Let's try and do that again. Go all the way down. So it goes a little bit under what it was supposed to, and then we just crank it up. No, that's perfectly fine. 330, okay. So the last one of the three main supplies is that one. It's just connected to this voltmeter here. And let's see, it should go from 50 to 250. There's also that voltmeter, by the way. We can probably show that as well if we are a little bit smart. We got some lamps here. That's annoying. Sorry about that. It's not that one. Oops. It is this one. So it should go 250, and this one goes a little bit over. Yeah, I'll of course have to play a little bit with the voltmeters here, but it's so far, if I look only on the voltmeter and pretend that I cannot see the other one, let's just try and dial this in for 200 like that, and then, okay, so it's giving me 10% more than I asked for. All right, that's how it is. See, now this is the J switch for 3. So when I push this in, see, now I am in amp meter mode, and now I have some serious resistance to that voltage. So now it's going to be fun. Let's try and play with this output here. This is output 2, and it's connected to my load. Is there a way I can show you guys this? I don't know. Let's crank up number 2. Let's just let's see. We will have 200. Okay, so unloaded, I ask for 200 on the voltmeter, and in reality I get 217. Okay, so let me crank on a little bit of load. So that is 25 milliamps, and we still have exactly 217. So let's crank up the power. Let's just load it half. So this is 50 milliamps, and we have about the same. So now I will push the J button for the second output. It should be that one, right? And then this voltmeter will now be an amp meter, and we should be about in the middle, right? We are in the middle. Look at that. And the voltage is not dropping that much. So this reveals the sense resistor is very low, and it is not causing a huge voltage drop. That is exactly what I was afraid of. See? We don't even have any detectable output. How cool. So it really works. So far, so good. Happy camper here. Wow, it is a beautiful power supply. A little bit big and a little bit heavy, but yeah, it works. Oh, let me show you this. This is only 10 watts. But what we could do is we could crank up the voltage to, we could probably do 300, right? So I will try and adjust for 300 here. Like that. Okay, so what if I turn off the load? We still have 300. Oh, that is nice regulated, right? And this thing was supposed to be able to do 100. So 100 milliamps, okay? It is 30 watts of output. Nice. And let me turn on and off the load while I show you the input power here. So it is 161. All the other outputs there are of course unloaded. Now I turned off my 30 watts. And now this is my idle input power usage. I'm still having a little bit of problems adjusting the outputs of the two main supplies in this unit. And if we look a little bit more at the schematic, it's also explained several places in the manual about the voltage range. So it's supposed to be from 80 to 350, like you see here, right? And then we got our power tube, the EL156. And this is of course controlled by the voltage compare and regulation tube, the EF804. So the problem is this system here isn't really able to give me the full potential. If I poke around with the two trimmers, the R15 or R6 and of course R13, that is the voltage adjustment knob on the front. These three in all the different combinations, yes, I can trim the output to barely 340, 50, something like that. But when I then turn down the knob, the main voltage output, then I get 150 volts or 200 or something for the other channel. There is also the negative side of all this. The negative supply is of course adjusted first before any of this here is adjusted, just so that we are sure that everything is correct. But it shouldn't really be that big a deal because the negative output only supply the voltage reference tube for the negative voltage reference. So it shouldn't change that much depending on if I have a little bit more or a little bit too low negative as long as this negative neon bulb regulator here is up and running, I should have my negative voltage and super duper fine. So what I've did first, I measured the output voltage, the negative 10, and I adjusted my P26 and P17 so that it goes from 0 to 11. Because this is a classic way that stuff is. It goes a little bit over and it goes a little bit under. There is no how to adjust kind of explain, so this is what I've done. Also, I like to show you in the upper left, maybe we should zoom in a little bit here and have a look. You can see the two rectifier bridges. They're called SSF, B250, C125. So that is a selenium rectifier bridge, and it only handled 250 volts, 125 milliamps each. So that is why they put two of these in series, and they have two individual windings. So the high voltage you get on top of C1 and C3, that is 650 volts. So they're really running this to the maximum. And by the way, there isn't any voltage drop over the DR1 inductor. I have exactly the same on C2 and C4. Also, if you pay a little bit attention to the way that capacitors they are arranged here, you will see that C3 and C4, that is actually that is a two-in-one capacitor, one can of capacitor, and then C1 and C2, that will be two individual smaller sized capacitors that is located on each side of those. So they can't really make the trick with the bottom side inductor like I really would like to have seen. That is a much better design. This will just require 4 individual capacitors, obviously. About putting those two rectifier bridges in series, you can see the top one and the bottom one, there is a little wire between these. And you know how it is with selenium rectifier bridges. There's a lot of leakage and the maximum reverse voltage and all those kinds of things. It's not that super tight with tolerances. So I don't understand when you have C1 and C3 in series, now you have a center point that is half the voltage. Why isn't that center point of the two rectifier bridges connected to the center point of those two capacitors? Then you will be very sure that the reverse bias for those two rectifier bridges is like equally shared. That is a much better way to do it. We have a drive problem, output drive with the EL156, and I think it could be because of low emission. That means we have an old dead tube. I have, of course, checked all the resistors and voltages around this tube, and it looks more or less normal. And I have exactly the same problem in the two main output supplies. And I don't have it in the third output supply, and that is using a different tube. So now I got the super good idea. EL156 and EL34, they are more or less compatible. And if you go and read on all the different hi-fi audio amplifier pages, you will see that a lot of people interchanged these tubes because the EL156 is impossible to buy today. So this is what I want to try and do. I want to replace those tubes. So to be able to do the replace, I of course just did a really fast hand drawn here. So this is the pin out of the EL156 and all the numbers and how it looks like. And this is of course a bottom view always, by the way, when you're looking at tubes. And then I look at my EL34, and it is of course a lot different. This is only the 8-pin socket is super easy. This is a very, very normal socket. And then I'm looking at this nice and fantastic socket right here. It is of course in no way compatible, as you can see, right, with this one. So we have a little mechanical challenge. How can I put in my EL34, this little tiny socket here, into this one? I need to build some sort of an adapter. And then I measured the pins. This is a brass M3, you see? It fits, and there's a nice contact. Some of these contacts here, they are a little bit loose. This is fine. So I think I will be able to make my own little adapter. So here is the bottom again of the EL156. And as you see, the 5 pins, yeah, okay, we got 2 of them missing, but I just call them the 5 pins because this is how it's defined. And then you have the circle. That is also an important measurement. And I had to look this up to figure out the right angles, because you can see those 2 markings here, they are not symmetric. I mean, you have more spacing here than 2 pins here. So to figure this out, I can tell you we got 26 degrees between those pins here. And with that information and the diameter, so that will be the official measurement for that socket, where you can see the different degrees between all the pins. And by the way, they're calling this 28 millimeter diameter, the circle, and this is not correct. So here's my little 3D design, my little adapter socket. This one should be able to fit into my unit. And then I'll put in some screws and see. The other 2 holes you see out here, those will fit to the 8-pin socket for my new EL34. So that is my idea. Maybe I should show you the measurements. See, it is 27.6. That is the circle diameter, and then you get exactly to the right inside the pins and all that. See, I added some numbers so it's easier for me to figure out what I'm doing when I'm soldering the wires. Just an easy way to prevent errors, right? So after the part is 3D designed, it's going through a slicer, and then I will start my 3D printer. So this is of course only a prototype, so I'm printing in PETG, so that is a high temperature filament. So all we have to do now is wait a little bit, and we should be able to see if this is going to work or not. So I'm still playing around with this little adapter thingy here. So here's my little 3D printed part. As you can see, it's got this steering tab. The reason why I didn't make this longer is I'm using this to figure out the length of the screws. So what I've done is I took my screws and I grinded them down and painted them a little bit here for isolation. And here also I had to cut these for a little bit of isolation standoffs, and that is the EL34 socket. So I think I'm ready to try and assemble all this and see if I have made my own little adapter thingy. So I can't wait to solder the wires and all that kind of stuff, but I think that's turned out quite all right. The reason why I put in all the pins, also the 2 missing pins, that is because the socket in my unit here hasn't been used at all at these 2 pins, obviously. So the spring there is really, really nice and strong, and that will hold the whole socket nicely in place if I leave these, if I have them mounted. So that is why it's not the most beautiful 3D print, but that is how it is when you can't wait. Just too bad. And it is PETG, so it's high temperature, and I did run it at very high over temperature, so it's melted really, really good and solid, so I could cut some really good threads in it, and it's really nice and stable. So that went quite all right. I really hope it will fit into my unit. So here, can you please hold the camera?
Yes, darling.
And then let's try and look. So there's this little thing that needs to go up. Ooh, where do I put my fingers? And then I just... Ooh, yo, 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 yo. This is fantastic. Well, let's see if it works. Of course it works with the EL34 in place, and all is of course a little bit improved. So this just proves the good old EL156. They just got a little bit low emission, and that is of course what I expected, but I still don't get entirely that voltage regulation range that I wanted. So I'm going to play a little bit with the other tubes. I already changed the EF806 and all that stuff, and of course there's no change whatsoever. So I'm just going to believe that the resistors around the voltage set potentiometers, they're just not so smartly adjusted. See, we can see 80, and then we can crank it up to about 300, right? So this one was a little bit low one, and I can of course, if you want to see this, so this is the pentode drive. See, and if I crank on this one, oh, that's the other way. See, here we go, and then we take the, see, then I can make it go 330, and then again, I'm going to take my output voltage adjustment and take it all the way down. See, this is not smart. So I'm probably going to play a little bit with the resistors around the potentiometer and see if I can get this up and running a little bit better. But anyway, I can also tell you that I can see somebody's been playing around with the power resistors. This is mine, the red one here. I've been playing a little bit with the anode resistors, and because I can see somebody's been playing with these, and this is the original, that one, the little 800K there. Ooh, don't touch. We got 650 volts there. It's gonna hit a little bit hard. So I think I want to end the video here. It's already been a long way through this one, but that is definitely a beautiful tube power supply, and I'm sure I'm gonna get this a little bit better. Thank you very much for watching. Please like and subscribe, and see you again tomorrow maybe. Bye bye.